Thank you. Is this on? So loud. All right, just a couple logistics. Men's restroom back here. You go all the way back, you'll see like some Chinese, I forget how that was described. What was that? Chinese slider. You'll see that, take a right, men's restroom. There's a gender neutral restroom out here by the elevator, and then a women's restroom back here. Cool, so why don't we get started? Oh, the Wi-Fi password. It was up here. Ah, there you go. All right, it's up here still. Cool. So there's Wi-Fi password. Okay, so before we get into the talks, we've got a couple plugs. So Laura from Klaviyo is going to talk to us about DevOps days.
Thank you. Hi, everybody. I'm Laura. I work here at Klaviyo. Thank you. I appreciate that. But that's not why I'm here. But if you do want to talk about Klaviyo, feel free to come and chat with me. But I'm here to talk about DevOps Days Boston. It is a 2-day conference. It's going to be September 24th and 25th. We're going to be talking about some pretty cool stuff. We're going to have a talk about expand contract patterns for the continuous delivery of databases. Seems somewhat relevant to what we're talking about tonight. We're going to be having a workshop on CI/CD with Circle CI. We're going to be talking about Kubernetes and containers. So if you're into that, you could learn some stuff there. And we're also going to be talking about some of the softer stuff like imposter syndrome and burnout and tackling those things. So again, if any of those things sound interesting to you, if you want to chat, I have some cards for 10% off. If you want to go to the conference, it's $250. You'll get 10% off. That's for 2 days. You get breakfast, you get lunch, you get snacks Monday night. So it's a pretty good deal. Yeah, so come find me if you want to chat, if you want 10% off. Thanks.
Thank you, Laura. Sounds like a cool event. Next, Jonathan from Wayfair is going to talk to us about PyFair.
Hello. So what is PyFair? Despite the slight naming collision with Wayfair, they're not actually directly related. What it is basically, it's sometimes a little hard to answer the question, what companies in Boston are solving cool problems with Python? So what we wanted to do is create an event where a bunch of companies get together and present what they're solving with Python, and a bunch of people can come to the event to learn what those companies are solving with Python. And it's all free, both for companies and individuals. So I wanted to, one, invite you to come up. The pycon.com or pyfair.com, sorry, will launch in about a week or two. But if you're currently working at a company and would like to participate, I really want to talk to you because we have a room for about 8 more companies to have a presence there. So the only thing is it's free, but it's a non-recruiting event, so it's just for techs. And we're going to provide you with a table, monitors, food, everything you need. You just have to show up and show off what you're working on. And if it sounds interesting to you, keep an eye open for the website that'll be launching soon. The date is October 20th, so there's a little bit of time to plan around it. If you'd like to present, just find me afterwards. I think I'm the only one here in a PyCon shirt, so it's a great way to find me.
All right, so before we get to our talks, I'd like to turn it over to Andrew just to talk a little bit about Klaviyo.
Hey everybody, thanks so much for coming out. Happy to have you. If anyone else has other meetups they want to host here, we have space. We're growing pretty quickly. We'll probably be out of space in this office in the next 6 to 9 months, but for now it's pretty darn nice. Yeah, so Klaviyo essentially is a data science company that helps brands grow faster. So it really means we ingest a lot of data and we process it in Python. So really we take all this data in, we go and run models against it, we store it in a whole bunch of like highly optimized data stores. So we have, petabyte of data in MySQL, petabyte in Cassandra. We store about 1 trillion counters in Cassandra. And this powers things like, hey, you want to go and find everyone who is a fan of your brand and their favorite color is green and they bought a pair of blue jeans a year ago. And hey, I want to know, should I give them a 20% coupon or a 40% coupon to go win them back? And so with all this data, we then send a few billion emails a month We send push notifications. We're doing like website personalization. We manage Facebook advertising campaigns, things like that. So that's Klaviyo in a nutshell. But really, yeah, I'm here to talk tech. There's a bunch of other engineers here. So yeah, if you want to talk about scalability, like we ingest about 1 billion data points every single week. We'll probably ingest about 200,000 events per second on Cyber Monday. Yeah, this is our fun time of the year. But anyway, welcome. Yeah, and enjoy the talks.
Thanks, Andrew. All right, so just some upcoming events. Our next event we're hoping to be in September, TBD. We're always looking for new speakers. So if you think you have a good talk, please reach out to John or myself. You all may know we usually do a round of introductions, but there's a lot of people here tonight, so we're going to skip that so we can get to the talks. So first up, we have Aaron Klein, who will present on advanced Django queries.
Actually, no, I just wrote one. That's good self-awareness. Yeah. How do I put it on?
You just unwind it, and then, yep, and then clip it onto your shirt.
The other part goes in my pocket.
Yeah, it should be on.
Hello? 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 Woo. Apparently it's on. So calibrate this, I think. Ah, okay, that works. I have to talk about technology. I don't think that's a good thing. Is this audible? No, that's not anything. Put on the laptop. Below the, oh, I can do that. Can people hear? Is that mic'd? Am I mic'd? I'm mic'd? Cool, thank you. Let me pull up my thing. Cool. So, sorry, still figuring all this out. I press the arrow, it does the thing. All right, cool. Hi, I'm Aaron. I'm here to talk about, I'm here to talk about advanced Django queries, which presumably people here know somewhere between very basic Django queries, advanced Django queries. Hopefully everybody here can learn at least something. And if not, maybe you can get a new perspective. And if not, then, well, I'm sorry. So I'm Aaron. I work for a company called Zagaran. You might have heard about us last month when my colleague Zags gave a fantastic talk about security and how Django helps you do that and how you can help you stay secure. We build software for anybody who wants software, basically. If you can dream it, we can build it, as long as it's software. And yeah, if you're interested in us for any purpose, like I said, we really do everything. Come talk to me or one of my colleagues who are all kind of right over here staring at me to intimidate me. Cool, so without further ado, let's get started. So give a brief outline of my talk first. So I'm talking about 4 main things. The first thing I want to talk about is related objects, right? You've got multiple database tables. They probably interact with in some way. How are you going to do this well? Because the bad way would be grab all of your things from one table and all of your things from another table and then do everything in Python. And once we've got that as our baseline, everything's a step up. So we'll talk about better ways to handle that. Next thing I want to talk about is bulk operations. So if you want to but you want to create a large number of database objects at once, you want to modify, you want to delete a large number of database objects at once, how do you do that quickly and cleanly? Third thing I want to talk about is performance profiling, which is extremely important because without performance profiling, you have no idea which parts of your website or software or what have you are the problem. You might think that, oh, over here is the slowdown, but it's actually somewhere completely different. And finally, I'm going to talk about lazy evaluation of query sets and what that means and how you can use it to your advantage, and possibly more importantly, how you can not get in trouble through lazy evaluation. So let's start with related objects. So first thing I want to talk about is doing essentially a SQL join, or doing a SQL join in Django. So you've got two database tables, and I'm going to here be using two fairly simple database tables. You've got a user who does usery things. You've got comments that the user makes, maybe on some kind of public forum or equivalent, and every comment has exactly one user. A user has multiple comments, so that's a standard forward key from comment to user. So the first thing is filtering on related models. So let's say I want to find all users that have a comment today. That requires looking for users that have a comment that such and such. So the way you do that is with this wonderful double underscore syntax. So you would say, sorry, I have it the other way, is that comments that have a user who joined today. Maybe because this talk was so great that you all joined the Zagrad fan club on Facebook. Do we have it? We don't. So you can see here, you say comment.objects.filter, user underscore underscore join. So that means it's finding comment whose user joined on this date. You can see here in the SQL that it does an inner join. So it joins the two tables, the comment table and the user table, and then it does a bunch of other SQL-y stuff. So double underscores. You can similarly use this for getting values from related models. So instead of doing a .filter, if you're doing a .values, right? Let's say you've got a user and you want to know the text of all of their comments. You do user.objects.filter whatever users you have. Values comment underscore underscore text, which will give you the text from the comment. And you can see again here, it's doing a left outer join, which for those of you who aren't super into SQL is like an inner join, but a little bit different. But it does the same idea as you've got the user table and the comment table, and you're kind of smushing them together and letting SQL do all of the hard work and just taking out the text of the comments from the users that you are interested in. The third thing that I wanted, the third thing with this, which is a little bit off, is double underscores are also used for something mostly completely different, but kind of similar, which is comparisons and the like. So for example, if you want to find all users that joined before today, or you want to find all users whose username contains the word, I don't know, Aaron, because you want to find your friends, then you can use this similar underscore underscore. So here, this is user.objects joined less than this date. So note that this is less than, not less than or equal to. So you'll find all users who joined before today, and you can see in SQL, it turns it into this lovely less than symbol. That's basically that for doing SQL joins. That's the gist of it. Just wanted to sort of put that out there as a lead into the next things I want to talk about, because this has all been you getting things from one table, you're getting things from the other table. What if you want them both? What if you have some users and you want to get all of their comments too? What if you have some comments and you want to get all of their users too? So there's a naive way to do that, which is you say, okay, I've got some comments. Let me get my comments, and then comment.user for comment in comment list. So that gets you all of the users for all of the comments. There's a problem with this, and that's that depending how many comments you have and how many users you have, this can be very, very slow. The reason for that is that this is order n. If you have n comments in your comment list, you are going to make n+1 database queries, one to get all the comments, and then one for every single comment to get its user. That's not fast. This can cause a lot of issues, as we'll see later in the performance profiling section. And not only that, by the way, if you have multiple comments by the same user, you'll make the exact same query to say, select app user where app user ID equals 2 multiple times, which is definitely not something you want to be doing. So how do we fix that? Specifically, how does Django give us a tool to fix that? And that's something called select related. What select related does is you've got, when you say, give me the comments, you can say, give me the comments and also the users while you're at it. And it does it all in one big database query using a table join. So you can see that's right here, is you say comment.objects.filter whatever, .select related user, and then when you run your comment.user for comment in comment list, it's only one database query. So you can see here, it's select from comment, join user, and where whatever your filter is. So that went from n+1, where n is your number of comments, which could be a very large number, to just one database query. And this is something that if you feel like, I don't know, your data, you have a page that's taking linearly longer to load the more users you have or the more somethings you have, this is a fairly common culprit. In particular, if you use something like Django REST Framework serializers, you run into this a lot because Django REST Framework serializer basically does this exact behavior. It does for object in list of objects, perform some operations. And if those operations involve any database queries at all, you're probably running into the situation we had before where you're making a database query for every single object. The solution to that, by the way, in general with serializers that I've come across is you can just stick your select relateds on the, you can tell the serializer, here's what I want my query set to be, and you can stick the select related on the query set. I'm happy to explain that more in depth later if anybody wants. But that's the gist of select related. Couple of things about select related. One is don't just do it all the time. Don't say, well, I really don't want to make a database query for every single comment I have. So every single time that I get my comments, I'm going to do .select related users. This is a bad idea, both because one, it will confuse other people who look at the code, who will be, what do users have to do with anything? I just wanted comments. And two, because SQL table joins are expensive. They are slow. They take up a lot of memory. And if you don't need them, don't do them. So use select related judiciously. And the best way to do this, again, we'll talk about this later, is using performance profiling to figure out, do I really need this or am I fine? The other thing about select related is they only work on an n-to-1. So a 1-to-1 or a foreign key from comment to user. What if I have a list of users and I want to get all of their comments? Select related wouldn't work. You can try it. Django gives you some kind of error. But the solution to that is something called prefetch related, which is similar, except that it works on an n-to-many. So if you have a foreign key going the other direction, so from user to comment, or if you have a many-to-many, you would use something, you would use prefetch related. So again, let's talk about how you would do this without prefetch related, right? You've got some list of users, and for each user, you want to know how many comments have they made ever. So that would do this, right? For user and user list, user.comments.count. Same issue though. This is order n. For every user, you're making a database query to say, hey, get me all of this user's comments. Hey, get me all of this user's comments. Get me all of this user's comments. This is obviously inefficient because you could just get all of these all at once. You could say, get me all of the comments. And that's exactly what prefetch related allows you to do. Note one difference between prefetch related and select related. Select related makes one database query. Prefetch related makes one database query per table. So in this case, with users and comments, it would make 2 database queries. However, 2 is still better than as many as you have users. So, ooh, I'm sorry, that ran off the edge. But it would be user.objects.filter prefetch related comment. And then when you run user.comments.count for user and user lists, you would get that it makes 2 database queries. First, it gets you all the users. And then it gets you all of the comments for all of those users. And Django does all the busy work of assigning those comments to users correctly so that when you say user.comments.count, Django's like, I got this. I don't have to make another database query to find this out. I've done all of the post-processing myself. So Django's awesome. And again, certainly here, don't go using prefetch related if you don't need it, because you'll actually be making more database queries than you would if you weren't using it at all. But it's a good thing to know about, and it's a good thing that when you're using, if you do performance profiling, or even if you're not, but you realize, oh, I need this to have this on the back burner of, oh, here's something I could use. Couple of comments on prefetch related. One is that, let's say you've got a list instead of a query set, which is totally a thing that happens. And I'm sure many of you have experienced the pain of having to say, okay, like make a new query set out of this list when, that's kind of annoying. So prefetch related objects is a function that you can call on your list that will do Django prefetch related for you, but without ever having to make a query set. So that's nice. The other thing is, and there's something called a prefetch object. I have never used this. I've used prefetch related. The prefetch object is for doing specific things to prefetch related that make it, basically it's for precise customizations of prefetch related. Like I said, I have never found myself using this. That doesn't mean you wouldn't find some use case. It just means that I don't really have a lot to talk about with it because there's a lot of different things you can do with a prefetch object. They're all in the Django docs. The Django docs are extremely thorough about a lot of things, but they're extremely thorough about prefetch objects. So I've tried to cover the basics. If you find yourself needing to use this and you realize that I haven't told you enough, go here. It will help. Yeah, that's really all I have about the prefetch objects. There's, like I said, I haven't used them. I'm sure there are use cases. I just haven't come across them. Cool. So that's related objects. Next, I'm going to talk about bulk operations. And so first of all, what does that mean? Why am I doing it? A bulk operation is fairly simple. It's if you have to do a bunch of things at once, a bunch of database calls at once. So let's say you want to create 5 models. So I'm moving away from user comment because I'm just working with a single database object here, a single database table, and I'm just calling it model. So for I in range 5, model.objects.create. Yay, I made 5 models. I could pass things to create if I wanted to, but I don't. This makes 5 database queries, which makes perfect sense if you think about it. You said do a thing 5 times, and that thing is make a database call. This is slow because you're making order n database calls for every object you're creating. You're making a separate database call, as well as the fact that sorry. No. Oh, no. I figured out what it was. Sorry about that. As well as the fact that if you have like custom save methods that do a lot of complicated stuff, you're doing that over and over and over, and it could just take a lot of time. So the bulk syntax for this is something called bulk create. MG refers to the model manager. So in this case, it would be model.objects.bulk create. So what this is doing is you make a list, you stick your model, you create your model objects in memory, and you don't put them into the database. And then you stick them all in a list. And then at the end, you run model.objects.bulk create your list, and it makes one database call. It says, okay, stick 5 new rows or however many into the database, and that's it. And it just works, and it's great. And it has a couple of downsides, and I'll get to those in a minute. But before that, I just want to say there's a couple of similar things. If we're talking CRUD, right? So create, read, update, delete. Create, we just saw, this is how you do a bulk create. Reading objects from the database, you're always doing that in bulk. Updating, so instead of doing like objects.modify field, objects.save over and over and over, if you have something like a common example of this is you have a large number of database objects and you want to modify all of their updated on dates to be today, you could just say, okay, like query set.update, updated on equals today. Similarly, you can do query set.delete and delete a whole slew of objects at once. This has the added benefit of if any of them fail, all of them will fail. So if you've got, on delete equals protect, then you try to delete a whole slew of objects, and some of them have foreign keys to other things. None of them will delete, which is kind of nice because you don't want to try to delete 12 things and only delete 11 and not really know about it. Yeah, so back to the downsides of bulk operations. I mentioned before custom save methods or signals. Bulk operations, skip those. This is because a bulk operation, unlike .save or .delete, isn't really Django doing anything. Django is just saying, okay, make a SQL query. And it makes a SQL query and it doesn't do anything else. So if you have custom save methods or you have custom delete methods or you have signals, bulk create won't call those. So solutions to that, one of them is don't use signals or custom save methods. Oftentimes, I apparently have a fan when I say that, but oftentimes that's good advice. Sometimes you do need them. And the solution there can be call them manually. So if you've got a signal, it's just a function. You can probably just call it from your code. So especially if your signal doesn't require any other database calls. So let's say that your signal is just logging, right? Every time I save a database object, I want to log that. You could just call the logger function manually, and it will do some print statements or write to a file or what have you. And you can just do that right before or right after you do bulk create. Same deal with delete. With delete functions, same deal with save functions. Also, a thing to be aware of is it's entirely possible that your save or delete custom functions make database calls. So that when you're modifying or when you're creating 10 database objects at once, each of your save functions is creating a related object. And now you're making 20 database calls when all you needed to do was really make 2, one to create the initial 10 and one to create the 10 related objects. So that's just a thing to keep an eye out for. And remember that if you're using bulk create and you really need those save methods, try to call them manually. And if you really can't do that for whatever reason, then it's possible you just can't use bulk create. Again, performance profiling will tell you most of what you need to know about this in terms of, oh, it turns out I'm actually fine. Oh, it turns out I'm really not fine. Another issue with bulk create you run into is that when you use Django.save, it updates objects in place. If you have an object without a primary key and you call .save on it, Django gives you a primary key. You don't have to make another get operation to say, hey, what was the primary key that I just created? Django just puts it on that database object for you, which is great if you're doing something like making a foreign key, because a foreign key requires that the object have a primary key. You can't put a foreign key on an object that hasn't been saved to the database yet. Bulk create doesn't do this. Like I said before, it's basically just a SQL query. Django isn't doing anything fancy. So you don't have access to the primary keys from your objects or anything else that may have changed about them automatically. And so a demonstration of this is if I make a model object in memory, I bulk create just that one object for demonstration purposes. That doesn't have a primary key. If I then save it, it does now have a primary key. Also note, this created this added 2 rows to my database that were exactly the same. If I had any unique fields, if this were a user or something, it would have failed. But a thing to be aware of is if you bulk create something and then save it, you will have just added it to the database twice, which is probably not what you wanted to do. But so how do we fix this problem of not updating the objects in place? Well, you just created a bunch of database objects. Okay, let me make a second database query and go and get them. This is probably still better than just doing .save, .save, because instead of making linearly many database queries, you're making 2. This is not as easy as it sounds. The reason this is not as easy as it sounds is you don't have primary keys. How do you find those objects in the database? Well, one option is, okay, you've got a different unique field. This was a user. You've also got a username. I hope you're not using username as your primary key. Because this is Django and you don't have to do that anymore. You have auto fields, yay. So you could just say, okay, I just created a bunch of users. Let me go and get users by their usernames. Okay, but what if you don't have a unique field? What if this is some logger and all you have is like a primary key and a timestamp and some text? Well, okay, you could add a UUID field, I guess, and like to the object and generate values on it before you save it, and then you could filter it. So now you have a unique field, except that's kind of a pain. Like, that's probably not necessary. It's a lot of work. Maybe I'm only doing bulk create once ever. It's like a CSV upload that happens once a month. And I don't want a UUID field on every single database object because that's, it takes up a lot of space in the database. It's a pain to deal with. I have to initialize it. Okay. So I don't want to do that. So you could select by most recently created, right? You just created, you know how many you created. I just created 6 database objects. Okay. Get me these 6 most recently created database objects. This is great, except race conditions are a thing. So I said, okay, create 6 database objects. Okay, get 6 database objects. And in the middle, some other process went, okay, create 6 database objects. And now I'm getting those 6 database objects, which are definitely not the database objects that I wanted. So the solution to this, and this is something that didn't occur to me ever. I was complaining about this to a friend, because this is a situation I have run into in multiple cases in real code bases, is you can use atomic transactions. And what that means, if you don't know, briefly, is that you can say, while I'm using this part of the database, nobody else can. So I'm going to create some objects in this database table. Other processes can go and create objects in other database tables, but this is my database table for now until I'm done with it, and you can't touch it. So if you do that, this works. I've tested it because I didn't believe it would work. But it does work, is that if you say declare an atomic transaction, and then you say bulk create 6 database objects, get the most recent 6 database objects, it will always be those same 6. Downside to this is no other process can use the database while you're doing that, which might cause other problems. It might slow down other processes. How much is it worth it for your bulk create? How much do you really not want to create a UUID field? Again, these are things you can figure out with performance profiling. These are things you could try and discover that it didn't work and undo. And so a lot of this is just, now you know all of these options, and you have to figure out which one is right for the right situation. but these are things that exist. So now you have more options, I guess, when you're trying to figure out what the right option is. Speaking of performance profiling, let's talk about performance profiling. So first thing is, if you know SQL really well, or if you're just like, hey, I wonder how many database calls this makes, there's something called connection.queries. You can use it in a shell. Important note: you can only use this if debug is true. So you cannot use this on production sites. So if you make some database calls, you select something and then you create something, whatever, you can say, hey, print me connection.queries, and it will tell you, okay, here are what you've done. So I did model.objects.create. It runs begin, which essentially says it declares an atomic transaction for the length of the create. And then it does insert into. This is great. It shows you the SQL query. It shows you how long it took. I happened to be working in a database that had 2 rows, so that's why all of my times are 0. But if you're making bigger database queries, that's actually useful. Works for all kinds of queries. So this I'm taking. Problem is, it doesn't show you the full site flow. So if you've got a website, you've got pages you want to load, and all this stuff, connection.queries won't help you with that. It only works in shell for the queries that you're making in that shell. So so this is useful, but it's certainly not perfect, and there's a lot of things that you'll miss. You can also have this done automatically, and I can tell you personally, this is what I do. When I run a Python shell, I always use -- print SQL. Note that this requires Django extensions. You should be using Django extensions. It's better. So if you use Django extensions shell plus, you can use print SQL, and every single thing that you do, it will just print for you the SQL query that you just made. This is great. Like I said, I discovered this at some point in the past year, and I can't live without it. And I basically, if I don't have it, such as when I'm in a production database, I just kind of flounder, and I'm like, I don't know what's going on. Yeah, so anyways, as you can see, this prints out for you, and it shows you the time to more than 3 decimal places. Again, like I said, not a number that matters here. But one kind of side note is print SQL uses connection.queries, and the way that it works is it sort of consumes connection.queries as it's populated. As soon as connection.queries gets something in it, print SQL takes it out, so you can't use them both. And remember how I said I always use print SQL? When I was trying to find an example for connection.queries, I was getting really frustrated because it was always an empty list. Because I was using print SQL, and print SQL was consuming connection.queries, and I'd do something, and it'd be an empty list, and I was I don't understand what's going on. Anyhow, yeah, but if you're using one, you presumably don't need the other. Like I said before, this doesn't show you the full site flow. So for that, I recommend something called Django Debug Toolbar. In fact, the Django docs recommend Django Debug Toolbar, which is how I found out about it. What this does is you include it in your site, again, only with debug equals true. And then on every single page on your site, your local or your testing site, there's a little thing on the right, a panel on the right-hand corner that allows you to see what SQL queries were made when you loaded that page. Or if you make an API call, what SQL queries were made when you made that API call. It's pretty quick to install. You have to add a total of about 10 lines of code, which is pretty great for something that's as powerful as this. Yeah, like I said, it allows you to actually follow your site's flow, unlike what I was talking about before. Here's an example. This is from some pet project of mine or another. As you can see, it's over here. If I clicked hide, my whole page would be there. You can see it shows you all of your queries that you're making. It shows you how long they took. Over here is what I find the most useful, is where it says, this made 6 database queries. The only reason it says 6 is because when I was looking for this example, I installed Django Debug Toolbar and loaded it up, and it said 275, and I was like, I can't show that. I can't be talking about oh yeah, performance profiling. This page takes 275 database queries, so I did some optimization involving select related, and I got it down to 6. I could probably get it down to 5, but I figured 6 was fine. It's also got this great feature where if you click this cell right here for select, it will show you, here's what came out when you made that database query. Here's the result of it. So you can see this is username me, that's me. I'm a super user on my own local site. Again, I would hope so. At last login, all the other stuff. So Django Debug Toolbar, I can't not enough emphasize how useful this is. This has helped me reduce time on, this has helped me improve performance on multiple projects I have worked on. So again, I recommend Debug Toolbar. That's basically what I have to say about performance profiling. I'm sure there are lots of other tools, but the main thing to know about performance profiling is you should use it, because without it, you're kind of guessing as to what's causing the problems. And it's entirely possible that what's causing the problems isn't even Django. You might have some image processing that's just taking seconds and seconds to process. Yes? Yeah? Debug Toolbar shell.
Yes. Well, basically what that shows you is when you make the query through the shell, when you make a query, it shows you the query, how long it took.
Okay, cool. Good to know. Django Debug Toolbar shell.
And it'll be there once you call.
Awesome. Cool. Thank you. So, excuse me. Last thing I want to talk about is lazy evaluation, which I mentioned all the way back at the beginning, and have actually been demonstrating incidentally and not talking about. The way that lazy evaluation works is query sets exhibit lazy evaluation. What this means is that if you have a query set and you say, hey, Django, get me all the database objects, Django goes, no. And what I mean by that is that if you say like, you know, like user list equals user.objects.all, Django doesn't do anything. It creates a query object, whatever that means, a query set, and assigns it to user list, and then goes to the next line. And the reason for this is that maybe if you never use user list for anything ever again, there's no benefit for Django to make that actual database call. Because you're never using that database call, and as such, it's a waste of time and memory. But the question was, wouldn't it be better to warn the user that they haven't, to warn the programmer that they haven't actually done anything? It would be useful, except that as soon as the programmer needs it, it will be there. That as soon as you say, hey, give me like print user list, Django goes, all right, let me make the database query first. So I think it's a good question, but I think that Django kind of handles that by virtue of saying that it's lazily evaluated means it's only evaluated when you really need it. Does that cover? Cool, thank you. Yes. You can always force evaluation if you want to. I'll talk about that in a bit. So as you can see, so model.objects.all, it doesn't make any database queries. By the way, if you find yourself using shell plus -- print SQL, you'll be like model.objects.all, and it will print out for you a database query. And you'll go, Aaron was lying. I wasn't lying. Printing something actually evaluates the query set, but you'll note that it says like limit 21 at the bottom, because it only prints out up to 21 database objects. So I guess that's just that print statements can kind of confuse things, but that's okay because you probably don't have print statements in your actual site flow. So anything that doesn't return a query set, by the way, is not lazy. So if I do a .count or a .get or a .annotate, I think is the one that doesn't, or aggregate, sorry, or .aggregate or what have you, that's not lazy, that evaluates immediately. So as you can see here, if I say n equals model.objects.count, boom, makes a count thing. Because n's an integer, you can't like catch the query on the, you can't have like n be like generic integer with query on it. You just want it to be a number. What my colleague said before about you could force evaluation, you could force evaluation. You could say, hey, list of query set, and Django goes, okay, let me make the query. Because if you're making a list, it's now a list, not a query set. Django no longer has control over it, so it has to make the query. Similarly, iter, if you've ever done, for user in user.objects.all do a thing, as soon as you say for user in, Django goes, oh, okay, I'm having iter called on me. I'd better, I'm being iterated over. I'd better evaluate the query. There's a couple other things that force evaluation. I'll get to those later. So you can see here, I call list of A, and it makes the query. Evaluation is done in place, and results are cached. So what this means is that when I say list of A, I have a list now, but my original query set also has made the database call. So A is now been evaluated. I don't need to evaluate it again. If I call list of A a second time, it doesn't make any further database calls because the results are cached on the query set. This is useful because if you repeatedly iterate over a query set, you don't want it making the same query every single time because that's obviously a total pain. Caveat on this is if you only evaluate part of the query set, so let's say you do a further filter, you're going to make different database calls and the results will not be shared between the two. So if you have, let's say, A equals model.objects.all and V equals A.values, so if you haven't seen values before, values, instead of returning you at your database query results as a database object, returns them to you as a dict of, column name and value. Despite the fact that these make the exact same database call when you call them, because they're both saying, get me everything from this table. If you say list of A, it goes, okay, let me make the database call. And then you say list of V, and it says, okay. Django goes, okay, let me make that same database call again. And the reason for this is that A and V aren't the same object. When you make the query on one, the other one doesn't know about it. Django isn't doing some kind of global tracking mechanism where it says, Django isn't keeping track of every single query that you make in order to be able to speed things up. Django is doing that on a query set by query set basis. So don't rely on this behavior to just say, oh yeah, I never have to make extra queries, because depending how you write your code, you very well may be making extra queries. Again, performance profiling. And the other caveat, I guess, about query sets is that calling length or bool on them will also evaluate the query set. So you may have heard that you should never call length or bool on a query set. You should always use .count or .exist, right? If I say how many objects are in my database, or are in this database table, I could say model.objects.count, or I could say length of model.objects.all. The first one makes a database query where it just says, okay, tell me how many rows there are. And the second one says, get me the entire contents of this database table, and then let me stick that into Python and have Python determine how long it is. So this is good advice. If you're in a situation like that, that person that told you to not use length or bool is correct. But there are situations where it is correct to call length or bool on a query set. And the reason for this is that it will evaluate the query set. And what that means is if you want the query set evaluated for other reasons, if you call .count or .exists, you're making two queries. You're making one to say how many things are in this table, and another to say get me the entire table. So if you've got this code here where you say get me all the objects, and if there are more than 3, you want to call this function, and if there are fewer than 3, you want to call this other function. Excuse me. If you said a.count up at the top, you'd be making 2 database calls. One to say what's in how many rows are there in the table, and the other to say what's in them. Whereas with this, length of A, boom, you evaluate the query set, cast the results on A, and then when you call some func and other func, you've already made the query, you don't have to make it again. Again, the answer to the question, but how do I know when to do this and when to do that, is performance profiling. If there's one thing to take out of this talk, it's do performance profiling if you feel like you need to. If you experience slowness in your thing, don't just go in your website or what have you, don't just go around saying, oh, I think it's here, I think it's there. Actually take the time to sit down and figure out what's causing the slowness. But again, just to bear in mind that calling length or bool at a query set, while usually the wrong decision, is occasionally the right decision. Last thing I want to talk about is one of the very few things of almost everything that I've talked about tonight has been a situation where you could do something well or poorly, but not one where you can really do it wrong. If you don't do select related, everything's going to be slower, but you're going to get the same data. Caching on query sets can actually lead you to get the wrong data. And where this can happen is that once I mentioned this earlier in a good light. Once a query set has been evaluated, the results are cached on the query set. What this means is that Django doesn't make that query again for you, which sounds great, except that what if other things have been happening in the database in the meanwhile? So A equals model.objects.all, length of A, evaluated the query set, caching the results on A. It's 2. I've got 2 objects in my database, party. I then create a new database object and then ask again for length of A. It's still 2. And the reason it's still 2 is because Django doesn't make another query, because it says, well, you already asked for length of A, and it was 2 then, so it's obviously still 2. And if this model.objects.create is happening elsewhere, maybe you didn't want to find out about it, but if you created that object and then you wanted to do something else again, and as far as you can tell, that object wasn't created, this could actually cause you to do things wrong and have problems. And it's not just for length of A. This could be if you want to do things with A, you want to do whatever, iterate over A, you're not getting everything. Or something might have been deleted and you still have it. And this is actually a big one that I've run into, is if you delete something somewhere else, and then I still have it over here, and I call .save, it will create it again. Because you've got a database object over here that's not in the database. Oh, hey, I've got a database object with primary key 8. There's nothing with primary key 8 in the database. OK, cool, I'll stick it in the database. So this can cause problems. This is something to watch out for. This is something you can't catch with performance profiling, because it's this is a bug. If you are running into this situation, something will break. And I don't have any advice other than watch out for the caching of the query sets, the same that you would any other kind of caching. As my colleague Zags likes to say, there are 2 things that are hard in programming: naming, caching, and off-by-1 errors. So yeah, I guess just watch out for this. Again, another thing to be aware of. That's all I have for now, for tonight. So thank you. And if you have any questions, please contact me. Here's my email. Please come talk to me afterwards. Yeah, thank you. Ooh, now we're bringing out the box. Oh, yeah. Yes, does anybody have any questions? Please raise your hand and you will receive the box. Back there was a. Hello. Yep.
Oh, sorry.
Isn't it great? I love that.
When the Django operators are exposed as query strings, sometimes you might see them like in an API endpoint. So.
What do you mean by Django operator?
I'm sorry, like the double underscore.
Oh, yes.
Greater than, less than, in contains.
Uh-huh.
And I was talking with a coworker who said that he was concerned that this wasn't RESTful because these are very Django specific. So that if you have a public API, it kind of forces your API consumer to know the Django operators. And I didn't really know what to think about that. And so is there a package that maps these Django query operators to something more generic, or is that something we should even be concerned with in a REST environment?
That's interesting. So you're saying that so you're saying that it would be like there would be a URL that would be like select objects underscore GT.
Yeah, that's what I've seen.
Interesting. So I've personally never seen that before. Okay. Django admin uses it. Mm-hmm. So I mean, I guess part of the question is this meant for, if it's meant for public, so if it's meant for only private consumption, so something like the Django admin, where you aren't really expecting users to manually navigate to it, or a separate, front-end JavaScript project to try to hit that API, it doesn't seem to me like it would be a concern, because it's just internal. Mm-hmm. If it is public-facing, that does seem to me to be more of an issue. I've never heard of such a package that would translate it into something, but part of that is I'm just thinking about it. Other than the double underscore weirdness, it doesn't seem to me like there's things like GT contains starts with seem fairly intuitive to me. That if I saw in an API, user with comments underscore GT like /5, I might not immediately understand what that was, but I think I would probably be able to get it. Assuming that that's the kind of situation you're talking about.
Yeah. All right. I didn't expect a hard answer one way or the other. I was just curious. Thank you.
So again, I don't know of any package. Again, if anybody else has heard of something, that sounds really useful. But yeah.
Okay.
Yep. Thank you.
I think like URL parameters for like filtering and searching operations is like there's no standard on it, because if there was, there wouldn't be things like GraphQL and stuff like that. So yeah.
That's a good point.
So one of the slightly more advanced things that I've struggled with a little bit, and and I'm wondering if there's an easier way of doing this than what I've done. So if you have a series of objects that you're joining through, so more than two,
Yes,
like
lovely.
you have 3 or 4,
Mhm.
the Django syntax, as far as I can tell, doesn't have a way to ensure that the middle object, that you're talking about the same middle object. It just evaluates each condition as whether it's true or not. Does that make sense?
So you're referring to a situation where you've got model A, B, and C, and you're doing A underscore underscore B underscore underscore C, and you've got
Something.
and you've got 2 of those in the same dot
same
filter.
query.
Okay.
Right, but you want to make sure that you're really talking about the same B in that. And the only way I've found of dealing with that is to actually have another lazy query set that pulls out the B objects that you care about, and then use that in getting out, in going after the data you want in the A. Is there any other like more convenient, clever way of doing that?
So I've certainly seen the doing it by querying on B. One thing that I can vouch for, I know this exists on many-to-manys, even with a declared through model. I do not know if this exists on general ones, but if you have a many-to-many, let's say you've got users and forums that the users post in, to go back to my original example. If you want to select users where forum starts with A and forum ends with B, if you do that in one dot filter, so user.objects.filter, forum starts with A, comma, forum ends with B, that will get you only fora who start with A and end with B. Excuse me. Whereas if you do user.objects.filter, forum starts with A, close paren, dot filter, forum ends with B, then you'll get users who post in a forum that starts with A and a forum that starts with B that are not necessarily the same. So I've never tried it with where you've got an intermediate object that may or may not be a many-to-many through model. One possibility is if you're doing it with chained filters, trying to do it in a single dot filter. I don't know if you're doing it in chained filter.
No, it
You're doing it in a
up
single
when
filter.
you're in a single filter.
Really? Okay.
Yeah. So like if you were to go one step beyond what you said and said, put in another condition, it would evaluate it as far as I know.
Can you select distinct on?
I can't.
Yeah.
I can't
So the proposal was you might be able to use some kind of dot distinct to do it. Maybe distinct on B. To clarify that, distinct takes arguments on some database backends and not on others. In particular, it does on Postgres and it doesn't on SQLite, and I don't know about MySQL or Maria or Oracle or anything else. But distinct can sometimes take arguments. Anyways, to answer your question though, I do not know. Other than what I said, and I've only come across that with many-to-manys, I don't have a clue other than filtering on the intermediate object.
So this would get you into the much more advanced than you want to hear, and it is possible to build more complex queries in Django without actually writing actual SQL, and that's without really writing SQL. It sounds like this is what you want to do is build an operator that does this. But that's well beyond, I think, the bounds of this talk.
Yes, this was certainly
next month.
This was certainly not meant to be an overarching, here is everything you need to know about Django queries, because I wasn't given 3 hours. There's a question back there, and I think there was another question off to my left earlier.
Oh, you can toss it.
Yeah, sometimes the top falls off, but
I got it.
Mostly fine. Good catch.
This is more of a comment.
Okay.
So transactions are wonderful creatures and slightly ugly creatures, more on the wonderful side. This is not transaction talk, so you put it in there. I think it was fantastic, and that was a really good solution for the problem.
Thank you. I didn't come up with it. My coworker
either way,
came up with it, but he's in Hawaii, so I can take credit.
So transactions are great. Be careful with your isolation level, because if you're on read, if you're on like the highest one or the one right below it, which is repeatable read, you're fine, because it'll never look at any other thing that's just been committed. If you're at read committed and you make a change to your model, and then you do something for 5 more seconds, and then some other part of the code makes a change to that exact same thing, and you then reread your object, which happens from time to time, you get that change. Repeatable read, you don't get the change. It's all in your transaction.
These are arguments that you can pass to.
So it's actually on the connect. It's like in the Django DB settings. There's like an options dictionary, which most people don't touch.
Okay.
If you do touch it, put UTF-8 MP4 in there. But yeah, transactions are great. Just if you're going to use them for anything other than creation, be careful.
Okay, cool. Good to know. Transactions, be careful. There's a sorry.
No?
You should be running in read committed. Okay.
Nope. Too slow.
Yeah.
Who's next?
Anybody else? I'll take it.
Thank you, Aaron.
Thank you.
All right, so in the interest of time, I think we're going to move into the next talk rather than take a break. If you do need to run and use the restroom real quick, feel free. But we're going to move right along into Jason's presentation. So Jason is going to present going faster and safer with Celery. We're looking for a Mac dongle. If anyone has one, we'd love to borrow it. Otherwise, we're going to take a quick break while we try and find it.
Thunderbolt cable would work.
Yeah. Oh, that's it. That's the one. Yep, we got it.
Does this work? Yes, it does. Hey, if anyone has to leave before they have a chance to talk to me, you can go to sign up for PyFair as a participator. You can go to bit.ly/PyFair, PYFAIR, and that should take you to the Google form to sign up. But if you can catch me, I'd love to talk. But that way, if you need to leave, feel free to use that.
Oh, hey. If you can hear me, don't raise your hand. If you can hear me, raise your hand. Just one way or the other. It's on. Yeah, it's hard. Okay. All right. Okay. Hopefully not many people have gotten that. Okay, well, I'm going to start. So this is, well, the topic had Go in it, but this actually fit on one line. So faster and safer with Celery. I'm Jason Held. I'm the Director of Backend Engineering at Circulation. If you like healthcare and transportation, that could sound fun to you, please talk to me. Okay, so who knows what Celery is other than the food? Okay, great, that's awesome. Who's used it? Good. So you can coordinate processes on your local machine or even clusters of machines really easily with Celery. It solves your processing and workflow needs in many different ways. If you've heard of RabbitMQ, then Celery will work really well with you. I'm going to focus more on the Redis side, but honestly, we're not going to talk too much about the brokers. The idea is you send messages to a broker. A message could be, well, in this case, it's a function, but encoded in JSON. Send it in, and some other worker picks it up. But it's message passing. Okay. So we're not going to go in the alternatives, but there's Luigi, there's Airflow, which can use Celery if you want it to. Dispy, Huey, RQ, which is Redis queue, so it's highly dependent on, guess what, Redis. And then Dramatique, which is a Python 3 only thing that says, we like Celery, but we want to be dramatic. So, so what are we going to cover? How to make your first task, how you can use this library to parallelize your workflow and process data, some ways to handle error conditions, because errors happen all the time. So any task, computable task you can do, so long as it's in the theory of computation computable, then yes, you can compute this with Celery. It might take a long time, but that's the whole point. If it's anything you do offline, and offline has various ways of meaning what does offline mean, you can put it into Celery. User uploads an image. You want to create a thumbnail, but you don't want to keep the request response cycle holding up on your thumbnail creation. You could put that task into Celery, and it'll do it for you. You have to create the thumbnail thing yourself, but you know, that's another topic. If you need to compute some expansive analytics, let Celery handle that for you, and you can deal with surfacing of those analytics somewhere else. If you need to do batch work, so you need to look at a huge file and do some batch work on it or batch computations, yeah, even if it's embarrassingly parallel. Who's heard of embarrassingly parallel? All right, it's like, this job is so parallel, it's embarrassing that I didn't make it that way. Like, I'm almost trying to think about it. It's like embarrassingly parallel. Okay, sorry. Celery can do that. Yeah, every single item in your whatever you're trying to do doesn't matter to anything else. So just do it, run it. Now, if you need to get something at the end, it's no longer embarrassingly parallel. So Celery's got a flow. It works with task queues. You could have a thumbnail queue. These are like literally things that are UTF-8able things. Probably ASCII only, but send an SMS queue if you're dealing with sending out text messages. What you need it to be. Any queue you want, you make it, it'll take it. When you call a Celery task, which is a function or a class that's instantiated some weird way, so think of it as a function. When you call it, it chucks it into the broker. It's a network call. Even if it's localhost, it's still localhost network. Then a worker who's looking at that queue will take it off the queue, and it's going to run that task. It could be on a machine on a different side of the planet, assuming you have machines on a different side of the planet. Okay. By the way, Aaron's slides are much cooler than mine. So creating a task and using it. So I'm trying to make these kind of like bite-sized, like you could maybe sort of run this if you squinted a little bit. It's very close. So we are going to import things from Celery. We're going to create a task. So shared task, you could use task also. PyCharm is saying like, that task isn't callable or not callable or whatever. So, but shared task apparently is just fine. So you create the function adding tasks, and you'll notice it's taking star items to add. So star within some Python magic means splattable keyword args, or splattable args. 1, 2, 3, 4, 5 args, 10 args, 100 args, just star args. So if you listified args, you get a list of your args. Magic for another day. So you could have an iterable of items, and you can sum them. Sum takes an iterable. That works out great. Now, if you give it an empty iterable, it'll probably raise a value error or something. But so in order to call it, let's say I want to add 1,000 numbers together. In this case, the first 1,000 numbers that are non-negative together. I just call adding task dot delay. Now, you're saying, well, I thought it was a function call. Why am I doing a thing on a function? Where did this dot delay thing come from? Well, that's okay. It's Celery's sugar-coating way of saying, put it on the queue with this argument, star range of 1,000, which will listify into the first 1,000 splatted. Then we're going to do tResult, which is the result object that Celery says you have for this task. And you're going to do .get on it, which says, I'm going to wait. You might have given me range of 500,065,555, but you're going to wait. The task might fail, but it might not. You're just going to wait. Okay, sound good? Cool. Remember, this is running somewhere else. That's why you're waiting for it, because it's not in local process, not usually. So yes, .get is very much blocking. You will wait till it finishes. You could actually give it a timeout equals 5, and it'll wait 5 seconds, then it'll give you a timeout error. And you can catch those things in your process. You really shouldn't be waiting on tasks if you can help it, though. You really should have the task do something to complete the workflow. But if you need it, you can use it. Canvas. With Canvas, not like HTML, but Canvas lets you do some powerful task flows utilizing the things we just made, like a task, right? So there's chain and cord. There's other ones, but I don't want to go over those right now. Chain lets you run a set of tasks, one after the other, and the result, the output of one gets fed into the input of the next. It's like one of the more functional parts of Celery. Celery is not that functional, but this is like the thing. Just keeps pushing to the next task. So group lets you run an iterable of tasks in parallel. That's kind of what I meant by the embarrassingly parallel thing. It just does them in parallel. Okay. You can tie the completion of them with a callback. So if you say, I want to do this, I want to do these 10 things, and then I want to do something else. That's a callback. So you could pass all of the responses of your first 10 tasks into a callback function or a callback task. And it'll be like, okay, cool, you gave me something, I can do something with that. So cord. We're going to use cord to get information from DuckDuckGo. See, I thought I would just give you a silly example of like adding numbers again. I thought that's not very useful. So we're going to do something a little more real-worldy where we actually make a network call to an external service. Who likes requests? Okay, at least half people here. So request is an HTTP library, very nice. We'll never get into the standard package library because it needs to go faster. So when we imported cord, you didn't see it, but we imported cord from Celery. We're gonna have this iterable, this parenthesis ask.go.s of q for q in hello world last one. So we're actually gonna iterate over each of these elements, and we're gonna chuck into this .s thing on the task that we just made. We're like, well, what's .s? Well, .s is this like signature thingy where it's it freezes the task without actually running it. So it freezes it with its arguments. It doesn't run it yet. You can pass that around actually if you need to run your task under certain circumstances or not run it or adjust it after the fact. .s. Then once we've pushed this whole iterable through, we say, okay, at the end I want to run this show results .s. And then I'm going to delay the cord to run it somewhere else, not here. Again, I'm going to block on the output of Go questions to get the response. So ask DuckDuckGo is going to take an object. In this case, it's going to be a string. We're going to call request.get on the DuckDuckGo API and pass it the question, and we want JSON back so we can consume it. We don't want HTML. We wait for the network response to get back, and we JSON, well, I guess it's already technically JSON, but we JSONify the JSON. Okay. We do that, and then as soon as all three of these are finished, now they're in parallel, so they're not waiting for the next one to complete. They're all running at about the same time somewhere, assuming you have multiple workers running. Then it's going to call this, and it's going to send them all of the responses from these things, and it's going to print them out and return them, just to show you that you can do something with them if you want to. So you're actually going to get 3 different JSON payloads, one here, comma, one here, comma, one here, sent in here, and you print them out. Who's used like functools.partial? Yeah, partial is like freeze, but more, it's like literally Python's way of freezing something. So signature, when I say freeze, it's like partial. Okay, chain. I know I went back to the adding task. Can't DuckDuckGo everything. We're gonna use chain, and we're gonna compute a set of tasks one after the other. Again, the output of one goes to the input of the next one, unless you do some funny stuff. So it's going to run this one, which is going to add 0, 1, and 2 together, put it into here, so 0, 1, 2, followed by 0, 1, 2, or I guess 0, 1, 0, 1, 2, 0, 1, 2, 3. But it's going to have the other ones here and here to it. And then once all 3 are done, we're going to get it. You wouldn't do this in real life because these are adding numbers. You wouldn't send them over the network to get this, but this is the idea. You can call a task with some sort of argument and get it back. So it's a chain. So if one element in the chain breaks, you're out. You can do some error catching, but you're basically out. Chain's powerful, but it's breakable. It makes sense. In terms of how Celery sends a composable message, like what it actually tells you, it sends it into Redis. So let's say Redis is a broker. It's some JSON object with here are the args, here are the quargs, here's the name of the thing, and here's something you have to do after the fact. It'll probably say, hey, your next task is this. And it's defined in JSON inside the payload. And when it's done, it says, okay, my next task is this. I'm going to pass it what I'm returning with. So it's three separate tasks. And if you want, could be on the same worker, could be. It depends on some settings. Celery lets you kind of play with greediness to reduce network I/O. But yeah, so it'll be 3 separate tasks. They might be on the same worker, in which case they're literally going to wait one by one by one, which is how it works. Cool. Okay. Custom runs. Sometimes you need some control. You said, hey, this stuff can fail. Like, what's that all about? How do I get around that? Well, okay, so there's task expiration, soft and hard time limits, because if you're using Celery, it's because you think you have a need to distribute your workload. Either something takes too long, or there's just too many of those things to do, and the user's waiting. Or you need a background task for something. So soft and hard time limits, there's retry logic, there's rate limiting, there's a time delay of the run. So you could do not a dot delay, but essentially a delay of the call. But say also, wait 5 seconds or wait 5 minutes to actually run this. So if you had a nightly email, that could maybe be something you do. I'm not going to recommend it, and I'll tell you why later. Okay, so we might go to some of the documentation for these. That's why these are blue, because they're links. So retry, in that task decorator, that shared task decorator we were talking about before, you can specify retry configurations on it to say certain types of exceptions it should be watching out for, how long until it should retry. So do I want to wait some period of time? How many retries should I do? You can also do in-house retry, which is not through the decorator. Let's see if we can get to the retry docs. Yeah. Okay, so the Celery docs, I think Celery is a great project. Sometimes they're misleading or harder to follow, and you have to play with things sometimes. So that's about all the bashing I'll do in Celery from a documentation perspective. So here you see an app.task bind equals true. Bind equals true says, this really is a class behind the scenes. When this thing actually gets populated behind the scenes, you use it as a function, but it's really a class. So I want to have self in there. Looks kind of strange, and if you have an editor, it might be like, I don't know, why is self here? This looks kind of weird, but it's real. You don't have to do this, but if you do it, you could do, open Twitter, update your status. Oh no, Twitter fail whale error happened. Self.retry and tell me what the exception was, because you can catch those exceptions. That's what I mean by you can kind of build in the retry logic yourself if you need it. You can also, again, with bind equals true, you can do default retry delay equals 30 times 60. So you're going to wait a little, well, actually a lot of bit. You're waiting 30 minutes till the next time it runs. That's okay. You can do that. You can also wait a minute on the retry if you really want to, under any exception. This is my personal favorite, where you don't specify bind equals true and it still looks like a function call. App.task, auto retry 4. So the same thing kind of saw up there. You give it your thing and just call it. And if it happens to hit your exception, it'll just auto retry 4. You don't have to do the bind equals true thing. Do it if you need the configuration step for it, but you don't need it. Specify your max fails. 5. I'm going to the documentation because all of this stuff is there and I don't really want to type it all out again. It's all here. If you do find the slides, the links will be there. Okay. Good. Retry back off equals true. There's some, they give interesting things. Retry back off max, auto retry 4, and these are all in the decorator. So if you're used to using decorators, which after this you will be because it's how you define a task, that's where you put it. You can do global retry stuff in the configuration file. So if you're using Django or something, you specify those things in your settings.py file, and Celery will pick them up. So you don't have to necessarily do the task if you don't want to. Okay. Ah, I'm lucky it came back. Okay. I didn't know where it would leave off. Rate limit. I'm not going to always go back to the docs, but so rate limit lets you do. I think I actually did it in 2 different slides. No, I didn't. Okay, good. If you're familiar with the idea of not running something over a certain amount of time, rate limit will work for you. So once a minute. I can run this task once a minute, and if I go over that, then I, meaning Celery, will wait that task out, and then it'll run it. So it's using the token bucket implementation behind the scenes. If you're familiar with like token and leaky bucket, then it's using token bucket, I believe. Leaky bucket would let you burst through. So you could do, I think you can do seconds, so 1/s, 10/s, 1/h for once an hour, that kind of thing. It looks weird because it's a string, but it's real. It's a real thing, it'll work. Work will just figure it out. There's expires. So if you say, you know, this task is great, but it really should only run in this time frame that I'm going to give it for. So I'm going to expire it with some, I guess you can say a time delta, but you really give it a seconds. I want to say expires in 90 seconds or expires in 4 hours. So by the time the worker actually gets to that task, if it's past its expiration date, it's out. It'll actually come up with a fail as I think it's a revoked state to say, this wasn't going to run, it was expired. That's very useful. I use it a lot at work when I either have multiple runs of something, or I'm like, you know, it really was only supposed to happen at this time, and I don't want it to happen now. Or I'm okay with it failing too. Sometimes not all your tasks are as equally as important as the other, but you still kind of want something to run if it's going to run. ETA and countdown. So I told you before you could tell something to run a little bit later. ETA and countdown will do that for you. So countdown takes an integer. I think you might be able to pass it a float. I haven't tested with it. It's like 0.5, which would be kind of weird, half a second, but you could do that. You can give it a time delta, so you can specify seconds equals 124. So no earlier than 124 seconds from now, I'm going to run. No earlier. So if your queue is backed up because you've sent too many messages into your queue, it's just, it might take 5 minutes. When I say backing up in the queue, is anyone confused? So Redis has idea of lists. You can put something into a key, which is a list. So Celery will use lists for its queue to say, if I'm on the send an SMS queue, I'm going to post a task into that. It's going to add it to the end of the list, and workers are going to pick off from that queue, and the list will get smaller and smaller and smaller until it's empty. So if it's backed up, it means you have a lot of things in your queue, and no workers are taking them, or they're taking them really slowly. That's not good, but that's a slightly different talk from here. So then there's time limits. So soft time limit and hard time limit. Soft time limit is actually a catchable exception. So you can import the Celery soft time limit exception, and you can do a try except around your really secretive code. And if you hit the soft time limit, you can clean up. So if there was a file you were messing with, or you need to send off an email to say, sorry, I couldn't finish it in time, this is your time to do it, assuming you can get that done in time too. This is all up to the programmer. You decide what a soft time limit is going to be, or don't make one at all and let it run forever and ever. Hard time limit, sorry, can't catch it. It's just going to fail. These are very useful. Use them at your discretion, but they're great when you need them. Sometimes I'll use them between expiration, time limit, that kind of stuff. Things where I'm like, it's okay if it runs late, but not too late. It's okay if it runs a while, but not too long. So if you're making a network call that doesn't seem to give up, this could be fantastic. They'll say, sorry, this took too long, I'm just out. Acts late, so when Celery takes a thing from the queue, it acknowledges to the broker that it took it. Which also means if your worker dies mid-task, it's already acknowledged the job. It's not going to try again. When I say dies, I mean like your process, your Celery worker, blah, 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 like Python module that you call. If it dies, like the machine goes away, that task won't start again. So if you do an acts late, it won't acknowledge the task until it's finished. That doesn't mean there will be double runs or anything. It just means if it comes back up, that task can be replayed. It also means if you had something in there that shouldn't run twice, you need to be careful because it's going to run twice. There's documentation on their site about acts late versus retry and which one's better. They can be used together. Just depends on what your task is doing. If you don't want something, if you can't have something happen twice, you probably don't want acts late. Or if maybe you do a caching mechanism at the top to say, oh, I've already done that and I've cached the result. So I go to the next part of the task. That works really, really well. Assuming your cache doesn't go away. Okay.
So the broker in the back end, we didn't really talk too much about it. How are task queues managed? Things are pushed into it, things are taken out. So NQ, DQ. RabbitMQ is the original broker for Celery, probably because rabbits and celery, okay? Programmer jokes aside, that's what the name was. In fact, the original internal like broker, like virtualization task thing was called Carrot. So yeah. Redis has full support, uses the subscription model subpub for Redis. If you're not familiar with that, please read up on it, it's cool. Amazon SQS, the simple queue service, everything with Amazon is S something S, unless it's something else. I think it's no longer experimental, but you should be wary if you're going to use it. It's also RPC, remote procedure call. I have not used that before. The back end. So we talked about running a task and getting a result back. Well, if this is all running and like a machine just takes your job and does its thing and returns, where does the result of that task go? Let's say it was really expensive and you're like, well, where'd it go? Well, you configure a backend. It actually stores the output of those tasks, and you can tell for how long to store it for instance, 10 seconds, 5 days, that kind of thing. There's Redis. So if you're already using Redis as your broker, you already have it available as your backend. You just have to tell Celery that Redis is your backend. You use Elasticsearch if search speed is really important to you. CouchDB, database, there's many others. There's many more backends than there are broker. Of course, the longer you hold these things, the more you're storing. So if you really are writing millions of tasks a day and you are storing these, you better be careful that your Redis doesn't explode under the pressure, or your Elasticsearch doesn't explode under pressure. Elasticsearch will probably be fine, but either way. So scheduling with Celery Beat. So we've seen sort of how you can run a task just like one-off. You could even put that in your script and run that task. But what if you need something to happen every 50 seconds or every 30 minutes? How do you make that happen? You could write your own configuration to do that, or you could use Celery Beat. Beat is actually part of the Celery ecosystem. It enables a thing called periodic task scheduling. So it can take a time delta. So in your decorator, you say run every equals minutes equal 5, or 15 seconds. There's also a cron tab-based version of that. We're not going to go over it, but you could use it as a cron base and say at this hour. And if it passed that hour, it won't run until the next day at that hour. Beat holds its own schedule in that machine, in a file. So don't wipe the file, because Beat won't know what ran last. It won't know what the schedule looks like. It'll actually restart and say, well, you want me to wait 15 seconds. You want to run every 15 seconds? Well, I just started up, so I guess I'll wait 15 seconds to run it. It's easy to use, but you probably don't want to run more than one. You should run more than one if you're dealing in a production system. But if you do, you need to do some locking your tasks. If you're running a thing every 15 seconds and it does anything moderately important, it's going to do it every single time, even if it's already run recently, like in the last second. So you should do some locking. If you have like a memcache or something, or Redis, which you probably have Redis, you could lock, use a key of like the task name, and say, I only want to do it if I can get the key, if it doesn't already exist. And I'm going to lock it for, say, 5 seconds. So the next time it comes around, it'll say, can I get the key? Oh, I got the key. Great, I can run this thing. Otherwise, I back out and return none or something. Or I guess you could return, sorry, couldn't get the key. But that's entirely up to you. So if you have like a billing, if you're billing a customer, you're changing database state, and you only want to do it when it's applicable, you need to do locking on it. So small example for Celery Beat. Once you know Celery Beat is very similar to just setting it up. So instead of importing shared task or importing task, you import periodic task. You then do the same kind of decorator, except you give it a run every equals time delta of seconds equals 32 on top of my check for file. So Beat, when you run Beat, it's gonna see this registered task and it's gonna build it up into its scheduler. And then you give it it's a bad example because I didn't give it an argument. Let's say I did something else, but either way, you give it a file path. It checks if it's there, tells you if it's there. If it's not there, it's not there. It's actually going to keep doing that, whether the file is there or not. It'll just keep telling you it's there or not there, depending on the state of the file system. So again, it's Beat. It just keeps scheduling it. It doesn't just stop doing it. There are ways in the community that they're trying to make it more dynamic in the scheduler. But if you don't do it that way, this is just going to keep happening, which is why, again, you might want to do locking when you're running these things. And I don't mean like from threading import lock. I mean like memcache or Redis or something of a distributed nature. Okay, so we got some monitoring. I should have said this at the start. If we have extra time, I will show you Flower and show you some things. Yes. Yep, task still runs. Isn't that great? The task still runs. So the question was, if you put a lock in the task is still going to run, so you're just going to back out as soon as that check on the cache fails. Yep, task is still going to run. That's why beat is great, but you have to be careful with it. So monitoring, we've talked about how you can enqueue something into the system. We haven't really run a worker, so we haven't really talked about dequeuing, but if you follow the Celery docs, which if we have enough time, I'll generate up a worker and we can see it actually take a job. So you want to know how your tasks are performing. They're in your system. They're actually doing work for you. When they run, what are they returned? Are they failing? What are their exceptions? Maybe you have a runtime error, and that's bad. That's always bad. So unless you expected it. Is it like, is that a Python? Exceptions should be silenced unless, shouldn't be silenced unless explicitly silenced. So, all right, so usually more important to know when they fail and how they fail, so get a traceback of that whole experience. If you enable Celery events, which I think by default is on, but you should check that, you can see Celery and its ecosystem from the outside, You can see what's queued, what's running, what's revoked, all these things, what the times were. So Celery Flower, it looks like flour to you, and you can call it flour. I'm just shallow and pedantic and read all about the naming scheme. They're like, oh, people are calling it flour? No, it's flower, but okay, sure, botanical variety. So you can call it flower, that's fine. What did I write? Got it. Well, heartbeat. I like beats. That's very good for Celery. Yeah, it really should have been more food-based. So Flower is a web-based tool, so we're thinking JavaScript and all that sort of stuff, right? You can see the events of the system in play. You can see the queue lengths for all your sort of queues, your SMS queue, your thumbnail queue, your super secret queue you don't want anyone to know about. See the failed task. When did they fail? What were their arguments? How did they fail, right? How many have you succeeded? When you use wisely, you even kick off tasks via the Flower API. Of course, the task has to already be defined in your system that it'll run. Okay, and that all the API stuff is on Flower's site, but we can try to run something. All right, so what's wrong? We've talked about a couple wrong things, but so far it's been, I think, a pretty upbeat conversation about Celery. Not perfect. Redis is not following AMQP. AMQP is actually a standard protocol. It's Advanced Messaging Queue Protocol, something like that. That's like that ACK stuff we were talking about a few minutes ago. That's all AMQP. And RabbitMQ is an implementer of AMQP. Let's say a worker seems to hang on a job. Sorry, that's just Celery. Or I guess the code on Celery, or maybe Celery is just hanging, because that's what things do sometimes. I haven't really seen that in production, but I've heard horror stories. Or Flower, hey, that thing, Flower, that looks really cool. It does historical events for us. It might look like it's being weird or wrong. Sorry, but I'm working on an Elasticsearch improvement. That's nice. Use Elasticsearch as the backend for Flower. Flower actually holds an in-memory heap of all of its task data, so if you restart Flower, you're gone. It doesn't remember anything. There is a persistence mode. I haven't had much luck with it. You might have more luck with it. It stores in like a Python shelb file. Shelb is in the standard library, so it's nothing magical about it other than it's Python. So I'm working on this. Hopefully in the next month or so it'll get merged, and then people can be happier. Because once you hit 1 million or so tasks, Flower starts to get slow when you search for things, because everything is all in memory and has to re-sort everything and re-filter everything every time you want to look for something. On the historical side, at least. On the dashboard, not so bad. Okay, the countdown on ETA and Redis. If you're using Redis, there's this thing called visibility timeout in Celery that's just there anyway. But for Redis, if you use an ETA or countdown that is longer than your visibility timeout, which we haven't talked about visibility timeout, and I don't want to really talk about it. So if ETA says, I want to run my thing at time delta XYZ, and then it'll run it no earlier than that, right? Or countdown 10 seconds. If your ETA or countdown is larger than your visibility timeout, every time you reach a visibility timeout, your task is going to run in a loop. Sorry. If you increase your visibility timeout to be like a week, that means if the worker goes down, Celery is going to wait a week before before redoing that task. So careful with that setting. I think for RabbitMQ, it actually doesn't matter. I think it's more of a Redis problem. At least it was on the Redis part of the Celery docs. Community solutions. So we talked about the whole locking thing. There's a Celery once project, which sort of puts that behind the scenes. You just give it a configuration and it handles the locking for you, which is really nice for periodic. We're just running a task. It's in Redis. So if you're already using Redis, you have it. There's Redbeat. Again, a lot of Redis stuff happening here. Redbeat is, it lets beat be distributed. So it actually stores the beat scheduler, like the task schedule definition. Like, I want to run this thing every 5 seconds. Stores it in Redis. So you could have multiple beats, and they're all going to pull from Redis. So if your beat goes down, there's still a scheduler up in the cloud somewhere. I haven't tried it. I really want to use it, though. We have a few at work, and we have to do a lot of this, but we don't use this yet. We're going to look into that. Airflow, haven't used it, but Airflow can use Celery. It might have a better API for a workflow you want to produce. Maybe it has a better batch flow or a better scheduling flow. You could use Airflow to do this then. Jobtastic, I've looked at the documentation a lot. It looks really fun. You can enable custom data inside of like a task update. If you like, it's like a status of succeeded or failure. Those are task updates. You could do a progress update in your task, and you could have client code that looks at that and says, okay, cool, I can make my progress bar now 50%, as opposed to I don't know where I'm at. So Jobtastic could be interesting if you're looking for a long-running user responsive job, and you don't want to build your own solution. This is fake data, but thought you'd appreciate a percentage of 77% faster and more reliable with Celery. I don't have any sources. I thought you'd appreciate that. Small and large companies leverage Celery. So there are problems with it, and you learn more as you go, and the community has things about it, but it's enterprisey. It works. It really does. Celery is used in production systems to process millions of tasks a day. This is on their website. You can trust them. Free yourself from blocking workflows as much as you can. Use Celery or something today. So like Luigi or something. Just do your research. Try it out. Try things out. See what plays well. And thanks. Okay, so we can probably do questions, I think. If you want to see any live coding examples or see what Flower looks like, we can do that too. This can be whatever we want it to be. So, yes.
I inherited this thing called Fabric.
Yes.
It's great if you have one ops person, but it's kind of not great if you have more than one. Could I use something like Celery to do like, hey, here's a workflow for all of my EC2 instances, or sync this file down from S3, untar it, and then kick Apache? Or is that like not really the scope?
Wow, like half of what you just said. We already have things for that. Yeah, it's funny how companies need to do like the same things sometimes, right? Okay, yes. So it's Python underneath, right? So you can import your S3 connection object from Godot. So yes, you could run a task. You need to somehow kick the task off. So whether that's by human touch or a Jenkins job, you can do that. Yes, using the chain thing we talked about, where it's one to assuming your chain doesn't break.
You want a broken chain, right? So
yes,
that's awesome.
Again, you can do error handling. We didn't talk about it, but you can do error handling. If you need a chain of things to happen, yes, you can encode that chain directly right there and hit go. And it'll do its thing, followed by the next thing, which untars, followed by some other thing.
Restart a service, or run Puppet, or
yeah,
whatever.
It's all Python code underneath. So if you need to import OS and os.syscall, don't do that. But if you need to do that, you can do that on the worker right then and there. And you can have jobs. You can go to another job which runs on a different queue. It doesn't matter. It knows where to go. So that's good. Yeah, I think you can do it. I think you can. Awesome. We can talk about it more though. Yes. So the Celery DevOps thing, I'll read to you. The Celery DevOps thing, your DevOps team, or yourself, if you are part of the DevOps team, has to know how the workers are performing. If they're dead, is Redis alive? Is RabbitMQ alive? But I guess if the code's working and the machines are up, it should work. Oh yeah, Salt. Salt is very cool, very Pythonic. If you don't like fabrics, you might like salt. Yes. Someone else had a question? Yes.
So I have a question. I use Celery with Django. So Celery setting is in here, Django setting, and I use Celery bit for scheduler.
Yep.
And so basically, one of the things I'm trying to figure it out is how can I set Celery bit time zone different than Django time zone?
Oh man. Okay. Yeah. Okay. I think we could do that. One way off the top of my head is so you're using Django, so the settings.py file sitting somewhere, which is where generally you'll get your configuration from. Celery can do its own file, but for Django, it's there. You can easily use it. You could say, through import sys, you could check if you're running as beat. You could check in your sys.argv if you've ever used it. It's very C-ish what it means, but what are my arguments that are given to me when I'm running my executable, right? So the first thing's like the name, because I am a manage.py, right? Something silly like that. But the rest of them are like, maybe it's the migrate command. But if it's really Celery beat, you'll know in the sys.arg. Oh, okay. Did anyone see like the weird cascade of colors? Okay. If you're using Celery beat, you can see that in the sys.argv that you are Celery beat. In which case, you can dynamically on the settings.py load say, I actually want my time zone to be this time zone. And so not Celery beats, I want it to be this time zone. I think that would work. I've done interesting things with sysargv and settings.py before. I think that would work. Try it out. Yeah.
Thanks.
Good. That's pretty good, actually.
How much flexibility do you have with the soft timeout?
Literally, you are going to program your own timeout. So if you're concerned that a network call might fail or not yet succeed is probably a better way to put it. First off, all your network calls should be timeout based. That's a different discussion. If the thing you're doing is taking really too long, or it's a local process and the computation is just taking really too long, I'd say test it out, or say, this really shouldn't take longer than an hour, or take longer than 5 minutes, or take longer than 10 seconds, depending on what you're doing. It's really going to be up to what you're doing.
Well, I mean, can you tell it, all right, if you hit the soft timeout, I want you to do other stuff for a full minute, and if you get cut off before then then do this other thing and report in this other way, or is it like you have 10 seconds and then you're dead?
You got 10 seconds and you're dead.
Okay.
Assuming the worker doesn't crash in the middle of that, which it shouldn't. That's the whole point. It's not supposed to crash. That's why Xlate can kind of help you out, or beat. So one way around that, I was thinking about that as I was writing this stuff up, but I didn't write up a soft timeout code snippet, but we could try it. You could actually create, on the off chance that you have this error condition that you're trying to do a cleanup or do some other thing from, create those as Celery tasks. And then when you hit the soft timeout, actually call that Celery task, put it into the queue. That's the only way you're gonna be able to get out of it. Or you might be able to do a self.retry and try it again. Depends on what you're trying. If you're really trying to do cleanup work, then try to push it through the queue if you can, unless you know it's gonna take half a second. If you think it's gonna take a little bit longer, yeah, push it through the queue. Probably push it through a queue that you think is actually gonna get it through. So there's a default Celery queue, which if you don't specify, it goes to the default queue, I think called Celery. Everything goes there unless you specify a different queue. And you configure these queues in the task decorator, in like this task routing thing in settings.py or the other Celery file, and just does it, just pushes it there. That hopefully answer the question?
Yeah.
Somewhat?
Thanks.
Yes.
I have something that was sort of inspired by something you just said, which is, can a task tell if it's being retried? So could you say, hey, retry this with slightly different parameters?
The answer I think is yes. Because when I was doing the Flower improvement PR, which I'm running at my job, by the way, we're running the version that hasn't been improved yet. It's working great, by the way. But when you have to encode state of the task, you actually see what Flower actually has in its own memory. So it has like retried and sent time and received time and the exception that was here. So I think you actually will know. You won't have access to it unless you're using the bind equals true in that decorator we were talking about, because otherwise it won't be a class. It won't behave like a class. Celery does some syntactic sugar. Unless you specify bind equals true, then it's like, all right, I know you would say that you're a function, but you're really a class, and self is your instance. So if you do that, yeah, I think you'll have access to a lot of information. I don't think you'll have access to all the times it did a retry. I think it's just the last one. You might have access to the number of retries it did. I haven't played with it. Yeah.
Yeah, thank you.
Was there a question over here? Yeah. I didn't see it. Did it make it? Yes.
It's not so much a question, more of a lesson learned that I want to share. If you have, like, exactly once processing is really hard, and if you have low tolerances for doing something multiple times, an often time, like for example, like let's say someone places an order and you want to email them an order confirmation email, and if you send multiple, and you want to send one
email,
so they don't freak out, right? Because if you're to order something, you get 2 emails, you're like, oh my God, did they just double charge me? A quick and dirty and actually pretty decent way of doing this is if you have a way of like creating a hash around your intent to send a communication, like let's say an order ID or something along those lines, you can pass that in as a parameter in your task, and the very last thing you do before you actually send the email is write that to Redis.
Mm-hmm.
And if that record already exists, stop, because something else already sent the email. And it's we call it like an intent identifier. That pattern's worked pretty well. It's pretty easy to implement. But if you ever end up in that situation, it's just something I've had success with, and I want to pass that along.
It reminds me of like the Stripe API.
What's
I've never used Stripe, but it reminds me of Stripe. But they're like the intent.
Yeah.
It kind of reminds me of that.
May have
So yeah,
stolen
going back to like how model definitions work. Let's say you're using Django and you're going to be pushing, you're using a Celery task to adjust state in some way. You don't pass your model object through Celery. You pass it the primary key or something unique about it that is useful, because one, your model might not be JSON serializable, and by default, Celery pushes its frozen version of that task into Redis as JSON. So you could use Pickle, please don't. Pickle would work, but it's security stuff. So use JSON, which is by default in Celery 4. It pushes it up there. You get it back. You should re-grab your object from the database, because it could have been an hour or 5 seconds or a second since you pushed it into the queue. So re-grab it, get the current state of the database, and if you are like, order email sent is true, fantastic, get out of there. But yeah, the hash, I think the hash is probably more maintainable. But if you don't want to use that and you actually had a thing where like, well, actually we already built I sent the email thing already, then it'll be in the database state too. But I don't want to belittle that. That is like, along with caching, like locking, that is like what you would do. So either have it in database state already, or have it in Redis as like a lock key. Yes.
And just to piggyback on that,
one added advantage of grabbing stuff from the database as soon as you get that is if you're dealing with regulated or protected data, then it's one fewer data store where you might have an entirely serialized user or something like that, and you can just pass the ID and you don't have to worry about that store. So
if you've heard of the word HIPAA, you should be scared, and this will help you. Okay. Yeah. Any more questions? Do we have I don't know if we do have time for a small live code. It's okay if we don't. Just curious. Not very long.
Famous last week.
We got more questions? Yes. Yes, absolutely. If you use Kubernetes, you just use Kubernetes for it. But yes, you can either play with the concurrency settings of an already running worker by increasing it. So by default, it's I think the number of cores. It actually does a pre-fork pool, so you have one PID work on a given worker. It has a PID, right? Your Unix PID. And by default, it has the number of cores of worker processes underneath it. So you can actually get some concurrency just by that. So 4 if you had 4, or 8 if you had 8. You can increase it to like 16, let's say. That's the general idea. You can keep asking it to pre-fork more to do concurrency. You can set up 2 different workers to look at the same queue, and now you have double the concurrency. And that's probably a little bit more maintainable from a DevOps architecture to say, I'm going to create more things, and I can then also remove them if I don't want them anymore. Celery also has the auto concurrency, like auto scale thing, where you can say, I want to be at maximum 10 workers on my one processes, or at minimum 2. And then as the load goes down, it will it'll kill off those sub processes, and load goes back up. It reforks those processes in real time. So you can do that. Probably safer to work with not using autoscale, but it works fairly well. Yeah, you can as many workers as you want. If you're using Docker or something, just make one more. Yeah, you can a worker can pull from several queues. Only the default queue, just one queue. You specify when you're creating it what it's going to pull from. --Q space my queue name. Yeah. Okay. Any more questions? Yeah. So yes and no. RabbitMQ does have the ability to do priority. Redis doesn't really. So what you might find yourself doing is creating a high priority queue. High priority, that's the name of my queue. And I only send high priority jobs to it. It's kind of like, okay, sure, I guess that works, is my solution to that. It works. You just have to be careful with it. If you want to maintain a RabbitMQ cluster or RabbitMQ service, it does support high priority or priority levels. So you could do it that way, and it's more built in. RabbitMQ is the full service. Redis is we do almost everything and do it pretty well. You can rely on Redis if you want to. And it does all the common things. It's like the priority and like the visibility timeout that get a little bit weird, but yeah. Others?
I think given the time, I think we'll break. But if anyone wants to meet and talk with Jason afterwards, encourage y'all to do that. Thank you all for coming out. Thank you again to Klaviyo for hosting us. Thank you, Jason. Thank you, Aaron. And thanks for coming out.